Hello everyone, my name is Aryan, and this is a work of the part of our course Signals and Systems PHN 313. The topic is challenges of ultra reliable low latency communication in relation to signals and systems. Currently, we are studying the course of signals and systems where we study about how communication systems in general work, the way the signals are transformed from one place to another, the modulations, the frequencies, and most prominently the transforms, the transfer that we use in the modern communication system. We're going to explore the ultra reliable low latency communication through the lens of signal processing and system analysis. The course name itself is signal and system. One thing very prominent about 5G is that it is trying to speed up the networks that we experience in day-to-day life. Be it right from starting from the 2G, 3G, or the 4G revolution, where the speed has always tried to be faster. With speed, there also comes the error that comes with the error or noise, as we call in the course structure. Noise also is a big issue which has to be solved in order for a very high quality network. So ultra reliable low latency. If we try to understand what exactly ultra reliable low latency mean is some a network that is highly reliable, something where you cannot compromise. So when it comes to URLLC, the most of the applications you see are where you cannot compromise on anything. Is this usually include like in medicine, in the technology field, like in the online surgeries where the doctor stays at one place and he's doing surgery at another place. Here you cannot compromise on getting a delay. Secondly, on trying to find low latency. I'll come to the definition of latency and how it is reduced in the certain thing. Moving ahead, so exactly what is ultra reliable low latency communication? It's a service category which comes under the 5G network, along with the enhanced mobile broadband and massive machine type communication. It is developed as a subset of 5G network architecture. It ensures some of the following services. The first is short transmission through the use of large subcarriers. Large subcarriers are used in order for this transmission to happen very quickly and in a very short time. Second is ultra efficient scheduling of data transfers. There's a very high reliability due to which the efficient scheduling happens of data transfers. Second is there is a transmission overlaps, that is more than one carrier, multiple carriers are used. Also the low latency. As I was saying, latency is basically, as you would also come through the definition feature, basically it means the delay that it takes from the user and the service. And in this URLCC, it is trying to keep less than 1 millisecond for very highly critical data transfer. The end-to-end latency between device and base station is around 5 millisecond for now, but with URLC we are even trying to take it to below 1 millisecond. Also, the reliability has to be greater than 99.99%. So it's highly reliable. So URLCC also offers high speed mobility and data rates ranging from low to medium. Endpoint data security is interested by URLCC features in mission critical application, even in defense contract missions where a drone or a live system is used, be it even autonomous vehicles which use live communication systems, they need this high reliability. Coming to the overview of key challenges. So, what are the challenges which come across in the path of URLCC? URLCC is trying to bring the even the Internet of Things, which is a very big thing. It is trying to bring things. So, what are the challenges? The first, the most two prominent challenges any signal system is the noise. That is, for example, in this case, the most of the two uh, features are nothing but challenges itself. That is the reliability, how to ensure that the network is reliable 100 percentage, that is 99 point greater than 99.99 percentage. Second is how do we ensure the latency, that the delay in time between the service and the user is very less, that is less than 1 millisecond. These are one of the two prominent key challenges, and we're going to study it of how your one of the prominent we are going to study latency using how signals and systems. So latency and reliability are two conflicting factors. That is, one is compromised at the cost of other. One is always compromised in classical communications to achieve the other. For low latency, shorter data packets are used in classic communication systems. However, shorter packets adversely affect reliability due to degradation in channel coding. Signal transmission reliability. Introduction to signal transmission URLLC. Ultra reliable low latency communication requires highly reliable transmission of signals, meaning minimal data loss and error free communication. So there are various modulation techniques in signals and systems that we use in order to make sure that there is minimal or negligible, although negligible is not possible, but minimal loss of information. It can be amplitude modulation, frequency modulation, as you can see in the next slide here. You can see the amplitude modulation, the frequency modulation, the phase modulation. So what happens is we have a message signal. There's a carrier signal, which when coupled with the message signal, you usually do a convolution, which gives us the amplitude modulated signal. This can be encrypted and decrypted, just like the WhatsApp messages that we usually see. And there are three types of modulation that we have even studied in a course structure of signals and system: amplitude modulation, frequency modulation, and phase modulation. Respectively, amplitude is change in amplitude modulation, frequency modulation, and phase modulation. Uh, these techniques help in reducing signal degradation over long distances or in noisy environment. One of the prominent problem of signals and systems is that the greater the distance, the more the chances of noise entering into a signal. So a greater carrier signal is required for it to carry the information without any distortion in the signal. Next on, we have signal to noise ratio. Signal to noise ratio is a measure of how much desired signal is present compared to the background noise. So, a higher SNR leads to clearer, more reliable signal transmission, which is critical for URLLC as it ensures minimal errors. URLLC systems aim to maintain high SNR by using advanced techniques like error correction coding to mitigate noise and interference, like modulation techniques for most part. Signal to noise ratio, as you can see in one of the graph. Next one, we have latency and system response. So latency is, as I already mentioning it again, latency refers to the delay between sending a signal and receiving the response. In your LLC, minimizing this delay is highly crucial for application like autonomous drivers. This is one of the very crucial field and very forefront of the field in terms of research. Telemedicine, where it also includes online surgery, and industrial automation, where a whole factory is run by Internet of Things, where you don't need any humans, where any delay can result in system failure because lives are at risk in this particular systems. The goal of URLC is to keep latency below 1 millisecond, as I already mentioned, ensuring real-time communication. Real-time communication is something which is very critical when it comes to Internet of Things and other VR, AR modulations also, and fast system response. In signals and systems, system response describes how quickly a system reacts to an input. It is often evaluated using the system's impulse response, which is the output of the system when it receives a brief input signal and impulse. The impulse response shows how long it takes for a system to reach its steady state, and in URLCC, the system needs to reach the state almost instantly to meet low latency demands. Impulse response and step response are two critical ways to analyze how a system behaves over time. In real time systems, it's important to have a quick response with minimal delay. That is, no delay is far better, but that's practically not possible, theoretically possible. So there will be certain delay, so we try to have a minimal delay. This relates directly to URLLC, where systems' ability to react quickly to input is critical for maintaining low latency. Systems with long impulse responses introduce delays which could cause communication lags, leading to failures in time sensitive applications like remote surgery or factory robotics. UNC systems required a rapid processing of signals. The processing of signals also is one of the key component of signals and systems. This happens across a wide range of frequencies. By using Fourier transform, which is one of the key tools that we have learned in signals and systems, we can efficiently handle signals without sacrificing. This is particularly important when managing multi-carrier modulation, where multiple frequency bands are used simultaneously to send data, as in orthogonal frequency division multiplexing. You can see the orthogonal frequency division multiplexing in this slide on the right bottom, where subcarrier peaks are there and sine function and side lobes are there. So these are closely spaced subcarrier overlaps. Subcarrier nulls correspond to peaks of adjacent subcarriers for zero intercarrier interference. Also, you can see the transforming function. Basically, it's that transform. A given signal is there, which is being transformed. And through frequency domain analysis. So usually from time domain analysis, we go to the frequency domain analysis for a better and easier way of analyzing the signals. URLLC systems can quickly adapt to changing condition, ensuring high data throughout and minimal latency, because it has to do a real-time communication system where it has to uh, give the signals and the responses and feedback in real time back and forth. So frequency domain analysis is the key. Trying to wrap up with this was one of the key component, latency, that we tried to study from the angle of signals and systems. Thank you.